In this instructional module, you will be introduced to Tabpy, an external service implementation which expands Tableau capabilities by allowing users to execute Python scripts and saved functions via Tableau's table calculations. Tabpy has what is called a REST API. It works essentially as a server for which Tableau is the client, executing operations in the background and returning results back to the Tableau user. To perform the requested operations, Tabpy has at its disposal the functionalities of the Python programming language, along with its ecosystem of computing libraries. During this module, you are going to troubleshoot 2 Tableau dashboards and work your way up to a fully functioning development environment based on Tabpy. The dashboard will contain table calculations with scripts with embedded Python instructions. Here is the anatomy of one of the scripts. It will always start with the declaration of the return type, be either an integer, a real value, a Boolean value, or a string. The first field is text, containing the Python code to forward to Tabpy and will be executed in the background. The numbered arguments are placeholders for your Tableau data elements. The subsequent fields are your Tableau data elements, listed in the order in which they're supposed to be plugged in into the text of your script. A script with embedded Python must return either a single value or a column with the same number of rows as your data source. Scripts containing embedded Python can take an alternative form. They can use Python to invoke Tabpy and query the results of a pre-specified Python function called endpoint. This offers the advantage of decoupling the data modeling from the data visualization activities, an effect that can be desirable for a number of reasons. It allows to store and reuse the results of computation that can be potentially expensive in terms of time or resources. It will also allow to delegate work across teams. You might be able to use and include in your Tableau workbooks the work of another analyst who can make it available for you through Tabpy. To get started with Tabpy, if you have never worked with Python before, you will first have to set up your development environment. This includes the installations of an up-to-date version of Python, an helper utility for the management of your working environment called pipenv, and a set of Python libraries, of which Tabpy is one, on whose functions your Python code will depend on. Let's proceed. Depending on your operating system, you might already have Python on your computer. However, Tabpy requires a recent version of Python 3. And so in order for you to follow along in this tutorial, we're going to quickly review the instructions required to install Python 3 on your system. You can check your available Python version by typing the command python-version in your terminal application. If you see anything different than 3.7, head over to the Hitchhiker Guide to Python, a website full of guidelines for beginners created by well-known developers of the Python community. Whether you have Windows or a Mac, the website will walk you through the installation of a package manager appropriate for your operating system, which you then will use to install Python 3 and a helper utility you're going to need to manage your development environment. The package manager for Mac is called Homebrew and requires the presence of the command line tools from the Apple development libraries on your computer. To satisfy this dependency, it is sufficient for you to type the command xcode select install in your terminal. I already have the tools installed, but in your case a dialog box will pop up asking you to confirm the installation of the software. After that, you will be ready to install Homebrew. The installation instructions are available on the website's homepage, and they can be just copied and pasted in your terminal like you did before. The installation will take a few minutes, during which the script will explain what it's doing and ask you to insert your password to perform the necessary changes. After the installation is complete, you can verify the presence of the package manager by typing, for example, brew help, and you won't be required to use your passport anymore for Homebrew. The actual installation of Python will be performed with the command brew install Python. As mentioned in the guide, there is an extra step required before you can actually use your own version of Python. The following command amounts to telling your terminal the location of your preferred Python executable. I recommend you to save this information in your profile using the following command. Once you're done, close and reopen your terminal application and verify that your system has been successfully updated by typing the commands type Python and Python version, which, if you follow the instruction for Homebrew, at this moment should actually report version 3.76. If you're on Windows, your setup instructions will be virtually equivalent. Instead of Homebrew, your package manager will be Chocolatey, and instead of the terminal application, your application will be called PowerShell. In Windows, there is only one operation required, which you can perform with copy and paste after verifying your execution policy as recommended on the Chocolatey website. Once your package manager is ready, you will be able to install Python 3 with the command choco install Python, which will also take care of recording the location of your new Python executable for you. Through Python, you now have access to an ecosystem of programming libraries that can be integrated in your system with a command called pip, which just shows how difficult it is to come up with good acronyms nowadays. As I mentioned before, you're not going to use pip directly, but you will use it through a little helper application instead. The helper application is called pipenv and has the property to isolate your Python projects from the rest of your system. You can use the instructions on the website to install pipenv. However, if you're on Mac and you have Homebrew, I would strongly recommend you to use brew instead with the command brew install pipenv. Working with pipenv has the advantage to minimize the chance of conflicting software if you end up working with Python programs again for another activity or another class. It will also ensure that you will be able to come back and reproduce the setup you're creating for Tableau through the feature that is commonly referred to as a virtual environment. So let's create a virtual environment for our Tabpy project. Let's start by creating a new folder. I am going to create a new directory in my Documents folder, and I'm going to name it Tabpy Workshop. Next, we're going to navigate to that directory by changing the working directory in our terminal application. You can just type cd space, cd stands for change directory, and then drag and drop the folder icon. Next, you're going to create a virtual environment that will make use of your new Python 3 executable by using the command pipenv-3. The command pipshell will then activate your virtual environment and make sure that all the subsequent commands that you will launch will only be encapsulated in the directory that you just created, therefore isolating all your operation from the rest of your operating system. Now you're finally able to install Tabpy, which you will do with the command pipenv install Tabpy. After a few seconds, your terminal will inform you that your system is ready. And you will be able to start Tabpy by just typing the name of the application at the command prompt. With Tabpy running at the background, head over to Tableau and inform it that there is now a new external service awaiting for instructions. You can do that by selecting the Help menu, then Manage External Service Connection, and finally filling in the information related to Tabpy. As we said, Tabpy and Tableau worked as client and server. So in this case, the server is on your computer, you're going to choose localhost. And once checked that the two applications are able to communicate with each other, you're ready to work with your first Tableau dashboard with embedded Python code. So navigate to the Tabpy project website at tableau.github.io/tabpy, and at the bottom of the front page, follow the link to download the example workbook. As explained in the accompanying blog post, the workbook contains two dashboards, the first of which displays an interactive map of 911 calls received by the Seattle Police Department related to a number of different crimes. Download the workbook and open it with Tableau. Zoom past the security warnings and meet your first error message. The dialog box is informing you that Tableau has successfully forwarded a request to Tabpy server, to which Tabpy responded with a no module found error. This is caused by the Python code contained in one of the calculated measures in your worksheet. In this case, the map is trying to flag locations that are hotspots for a specific crime based on the number of 911 phone calls recorded within a specific radius from the location. The likelihood to be in a hotspot is computed by making use of a clustering algorithm that comes from a popular Python library for data science, scikit-learn. So let's open a new shell in your virtual environment and install scikit-learn together with its dependency, numpy. Remember to always begin your terminal sessions by using the command pipenv shell in order to direct all your following operations at your Tabpy virtual environment. Then proceed with the library installation by typing pipenv install numpy sklearn. Once you're done with the installation, switch back to Tableau and watch as it displays your interactive map of crime hotspots in Seattle. Take a moment to observe how different locations are flagged on the map based on the different values specified for the variables on the left-hand side. Here I'm rearranging my desktop to let you see how the Tabpy server in the background processes in real time the data it's receiving from the workbook. As I select different crime types or modify the radius over which the statistics are calculated, a different slice of the data table is forwarded to Tabpy, which in turn return labels used to highlight different spots on the map. Once you're done pondering over the fate of the guy that contributed his mugshot for this dashboard, switch over to the tab titled Breast Cancer. Notice how a new, different error box pops up. This time, this dialog is informing you of a missing endpoint. In this scenario, you are looking at a classifier system whose task is to return a diagnosis for breast cancer based on the characteristic of the samples you provide. However, unlike the crime hotspot example, the model has been pre-trained with data that are different from the ones in your workbook and should have been deployed to your Tabpy server so that it can display its prediction in your dashboard. To fix this issue, you're going to use Python to create a classifier system and are going to deploy it to Tabpy with the name diagnostics demo, so that you will be able to obtain predictions for the diagnosis related to the specimens in your workbook. The original blog post on the Tableau website for this example workbook contains all the information related to the data used to train the classifier, as well as the Python code to deploy it. The code, which you can still obtain from the blog, comes in the form of a Jupyter notebook, which, besides introducing an additional technical layer with its own complications, is unfortunately out of date. Therefore, we have extracted the portion of code relevant for this exercise, fixed some bugs, and uploaded the results along with the training dataset as additional material for this week's module. Download and open the file called Tabpy Resources and move the files related to the breast cancer dashboard to your working directory. Use a text editor to inspect the content of the file breastcancerexample.py. I recommend the use of a text editor like Atom over a word processor like Word. Notice how the first few lines repeat some of the instructions invoked by the calculated field of the crime hotspot dashboard. The only new element is the pandas library. By now, you should know how to install a missing library for your project. Open a new terminal tab in your working directory, activate your virtual environment with the command pipenv shell, and then use the command pipenv install pandas to download and update your working environment with your missing dependency. Go back to your text editor and review the other instructions contained in the Python source code. The first thing to notice is a call to the Tabpy own developing library. Second, you will see a direction to read in the training dataset, along with the appropriate reference for citation. Following that, there is the definition of a list of different scoring metrics that will be useful to rank the machine learning models, the definition of a handful of classifiers, and then, at the bottom of the file, the definition of a function that uses variables like the shape and the thickness of a cell from the Tableau workbook as inputs and returns a diagnosis to display on the dashboard. The last line of the script is the solution designed by the Tableau developers to deploy the results of our data modeling work as an endpoint on a Tabpy server. To have the script perform its work, you simply switch back to your Tabpy virtual environment while your Tabpy server is running, and type the command python followed by the name of the file, breastcancerexample.py in our case. The script will generate some output related to the performance of different machine learning models implemented, followed by a confirmation about the deployment of your endpoint diagnostics demo. To observe Tabpy in action using the newly developed endpoint, reopen the workbook to the Breast Cancer tab. Notice how the diagnosis field is no longer empty, and notice how it responds to the changes we make to the test results. Let's review what you just learned. You work your way through two data visualization examples with extended functionalities provided by the Python programming language. In the first data visualization, a calculated field was making use of a Python script to process selected columns from your dataset through Tabpy and applying a label to each row. The labels were then used to update the visualization of your dashboard. In the second, a calculated field was querying Tabpy, which in turn responded through an endpoint. An endpoint is a Python object. It must make use of the Tabpy development tools, but in itself can be the results of the work of another analyst of your team and can be deployed through your computer or via a remote server.